So we have IQ and relational reasoning. So the first way we compared was the type of intelligence that's like focused on. So with IQ, there's more of a focus on crystallized intelligence versus fluid processing, whereas relational reasoning is more focused on fluid processing over crystallized intelligence, or the concept of crystallized intelligence, which can be debated. Then we looked at the conceptual framework. IQ is a specific test, is a specific measure, whereas relational reasoning is a concept of processing that isn't inherently a specific measure. We took the TOR, which is a specific test, but that isn't synonymous with relational reasoning itself. Then we looked at the type of problem. IQ is more of a schooled approach, like when on the problem mapping framework, whereas relational reasoning is more of an unschooled approach. Then dependence on recall. IQ is more dependent on memory and recall. Relational reasoning, on the other hand, is less dependent on that. Then the reliance on cultural components. IQ is highly intertwined with cultural components, and that goes back to the history as well, with like how much it changed and how it literally had to be developed from like country to country because of that reliance. Whereas relational reasoning is less inherently dependent on cultural components than historical applications. IQ has been used very problematically with eugenics, racism, classism, all of those things intertwined. Even though it started wholesomely, but now it's not, or it wasn't for a while with the Nazis. Anyway, relational reasoning, as far as we know, has not been misapplied on any large-scale ways like that. And then finally, educational applications. IQ was originally meant to detect and diagnose intellectual and developmental disabilities. I believe it still is. And relational reasoning is also used to detect and diagnose learning, intellectual, and developmental disabilities, I think. Yeah.
Nice, thank you. And then, it was great. And then Emily,
So
what was your initial thought? What did you think about it?
Yeah, we were like originally discussing what it means, the idea of crystallized intelligence versus fluid processing, and how that relates to IQ, and how originally a lot of people, or the public stance was that intelligence is like a set thing and it's unchangeable, and that's more what the IQ test relies upon, and whereas for relational reasoning, intelligence, or at least knowledge processing, is a fluid process, and how the test itself measures in a more fluid way.
Perfect, nice. And generally you thought what they did was correct,
Great.
no major errors? There was a question from last midterm, like how much do I write? What do I need to get my point across? If there is a compare and contrast question about this, having this little bit of information for each one, like 4 words is enough. As long as you identify the main point, identify the point of comparison, and then also describe the main point within each topic, that's great. So in terms of answering a question like this for the test, this would be sufficient. Again, the only consideration that I would additionally levy here is that the fewer words you have, the less words you have to like describe your point. So sometimes it may be useful to add a little more information, sometimes it's useful to not. All of these I think are fairly well constructed even though they're limited.
Hello. So our general definition of transfer is the process of using knowledge acquired in one situation and applying it to a new situation. And we just have some examples that we categorized as positive, negative, far, or near transfer. So first, I'm actually going to go through the definitions. For positive transfer, it's basically when transfer is helpful. Negative is when it isn't. Near is like small steps across highly similar tasks, while far is resemblance of tasks is less direct. And then we also have like 2 other types of transfer, which is extraordinary and everyday. Extraordinary is like rare rare situations where, yeah, like for example, like when Newton was like sitting under a tree and he got hit on the head by an apple and he was like, oh, gravity. And every day is like highly predictable and it's like less dramatic than extraordinary transfer instances. Okay, so the examples that we had were sketching in my free time and applied knowledge from my architecture class and learning about line weight and proportion. And we said that was positive transfer and it was also near.
So just to summarize here, the idea is basically, does it say watch sketching? So like
Yeah.
drawing, engaging in sketching, then going into an architecture class, you're learning things or you're applying things that you learn from sketching to architecture class when you're actually drawing
Yeah.
different things, right? Different, and so it's near because you're doing the same process essentially, just maybe drawing a different thing, and it's near because you're engaged in the same
Yeah.
process. Okay.
Okay. Do you want us to go through the other three?
Maybe do the negative and
Okay.
and near one. That would be a good one. The third one.
Okay. Thank
Oh,
you.
we know that one. Yeah,
Okay.
maybe just do the second one. Just do the second one.
Okay, second one. All right. So our example was making your bed and applying that knowledge to folding your
Close.
Oh, yeah, and then applying it to folding your clothes. And we also said that was a positive transfer and near because they're both folding things.
Okay. Nice. That's great, everybody. For Claire and the team, the two teams. I think we'll skip the secondary one. The key points with transfer here are again, there's this big focus here on identifying attributes in different situations, identifying features, and when we transfer information, we are identifying features or processes in one scenario and then applying it to the next. Right? So this is great. If there's a question about this, there might be a question about justifying why something is positive, justifying why something is negative, et cetera, et cetera. Do we all feel comfortable in being able to do that? That was part of the transfer assignment. Okay, cool. Let's go to the antinomy and antithesis problems here.
We were in the second group for this, so we only were able to put down two things. But for antinomy, since it's binary and like two opposing ideas, I guess, we created two sets and then you have to place the object just within the set. And basically, this set all has horizontal lines in the shapes. So that one would go there. And then this one's vertical. And you can't really be in between for that one. And then
So just to clarify, the problem is you have two sets with distinguishable features, and the problem is which set does each object belong to?
yeah.
Okay, perfect. Thank you.
And then for antithesis, we just had like a spectrum, and then on one end it's silent, and then the other end is loud. And then you have to you have to see which one of these words can basically fit in the spectrum. And quiet's only one that's a little more than silent, but also not loud.
And can you say the options again? The first option is?
Quiet, then bulky, and musical.
Okay, do you want to explain why the other ones don't work?
I mean, bulky has nothing to do with volume.
Okay.
And then musical, like, has to do with sound, but it's not like the level of volume. This is only.
It's not
one
loudly,
that's-
it's not amplitude or whatever term
Yeah.
we're going to use. Okay, nice. Cool. Thanks, Ava. Okay, let's do the anomaly group. Let's focus on two of the problems, and then we'll quickly do the analogy group, and then we'll want to spend a little bit more time on the four forms up here.
So we did the anomaly example problems, and we started with identifying what anomaly and was in relational reasoning. And we had that it was to identify which element of a set does not belong within the set. Do you have a preference for which ones?
Whichever one,
Okay.
whichever two. Do one
linguistic.
non-linguistic.
Okay.
Yeah.
For our
Bless you.
non-linguistic of the anomaly, we had 4 shapes, and 3 out of 4 of the shapes had 4 sides, and then we had a triangle, which didn't belong because it had 3 sides. And then for our linguistic, we had where, were, where, and where, and these 3 all the pronunciation was the same, and then this one, the pronunciation was different for were.
Nice.
Is
Perfect. Yeah.
that were you content?
That's great. Thank you, Diana. Do you want to, leave it on the table? So essentially here, what you've done is you've created the problems, and then you've given us the justification, which is exactly what we are looking for. Are there any questions about how these are or are not anomaly problems? Anybody feel that they are not? Right? And like I was saying, anomaly and analogy are a lot more straightforward. Okay, let's move on to analogy.
So we did analogy, and that's just a recognition of the similarities between 2 objects, ideas, events. And a linguistic example, we did this in class, but I would think we should note this one. We didn't do this one, but somebody else did, but it was a good example. And saying the question is, the man was confused on his work and replaced the underlined word and retained the sentence original meaning. And the questions are puzzled, frightened, delighted, and happy. And while utilizing the context, you find the similarity within the question. And then for non-linguistic, kind of same thing. For this question here, if the rule is +2, 2 to 4 is the same for 6 to 8, and that's it.
Nice, perfect. Thank you. Great explanation. So again, core point here is you can take the same structure. If we're thinking about being able to construct a problem, you can take the same structure, fill in different points, different values. Like we did not have hope. Did we have? We did not have hope and hopeful in our. We did? Oh, we did. Scratch that. You could take this and replace it with different words that have different analogistic comparisons to them. You can take the same format, is what I'm saying. This one, if you want to construct a linguistic sentence that's replacing words, or if you wanted to say, here are 4 sentences, or here are 3 sentences, pick another sentence that models or maps similarly to how these other sentences are constructed. That's also an analogy problem. Again, the idea is identifying relations between objects that are similar or constructing them, ones that are similar. Does that make sense to everybody? So we spent a little bit of time. I'll just do this. I'll do this one. I appreciate everybody's work for this, but just for time's sake, we will speed this up. So we established at the beginning of class that the core functionality, comparing and contrasting for, is the exact same as comparing and contrasting to, right? We're identifying a point of comparison. We're talking about how it applies to each one. Relationships between objects is basically definitional. We could just say, what's the definition? We could say the relationship between similar objects, relationship between one object being dissimilar, the relationship between objects falls into a binary, the relationships between objects falls into a continuum. Does it make sense how one point of comparison applies to each one? I just want to make sure that the structure of this problem is clear. If you don't understand it, you can point that out now. If you want to send me an email afterwards asking for additional explanation, I have office hours. I will make extra time, and we can do that at a later time. Now, I'm looking at the majors one, and what I'm assuming, yeah, I'm a little confused on the specifics for the majors in biology one. I know we talked about it, but I think the implementation was slightly off. So let's just skip that. Basketball, I think we're going to need more information on like what exactly the point of comparison is. Like, yeah, we can skip that one too. Complexity, again, okay, I think this is a good one to continue with because like it doesn't have to be super complex. The point of comparison can be pretty straightforward. The complexity of relational reasoning, it is a simpler form of relational reasoning. Anomaly is also a simpler form of relational reasoning. I've been saying that throughout this entire lecture, the entire class. Antinomy is more complex, antithesis is more complex. Does anybody disagree with any of those statements? Okay. Does everybody see how you can have the same answer, same description for each one, right? One of these does not monopolize an answer. So like, whatever you set your point of comparison to, complexity being one, like that's going to dictate what your answers are. I like this one too. This one is the infer step. So analogy, anomaly, antinomy, and antithesis all have the same four-step process, right? Infer, map, encode, apply. This point of comparison is saying, if I look at the infer step, what does that actually look like in an analogy problem? When I infer in an analogy problem, I'm establishing relationships. In the anomaly, I'm establishing commonalities within the set because that allows me to identify the one that is anomalous. I am additionally establishing commonalities in antinomy, and in antithesis, because it's a spectrum, I am determining the nature of the continuum. Is that clear? I think what I would like for us to take away from this is that if you're having a real tip here, think about what is it that all of these have in common. I think this one is a great example because there are three other steps that all of these share. So if you're in the midterm thinking, oh, what are things that I can put as a point of comparison? There are 4 steps. Infer is one of them, and we could very clearly see how they relate to each, or how they're applied in each one. So I don't want to hear, I couldn't think of any point of comparisons. I'm literally telling you 3 points of comparisons. You know? No, you cannot use the examples that people. Then I'm not testing you on anything. I'm just, like, I don't even need ChatGPT to do that. It's just copy and paste. But you hear what I'm saying, right? Like, I don't feel like I could be any more straightforward here. The 4 steps, they've only showed one of them. If you really need a point of comparison, there are 3 other steps. I'm not going to take a step forward there, right? We're clear. Yeah, yes.
I know you said some of them have similar characteristics. Do we have to discuss like how they're different, but also how they're the same too, or just how they're different?
If your point of comparisons all end up showing that there's differences, that's fine. If your points of comparison end up showing that like they're all, what we want to avoid is just a point of comparison where it's like super simplistic, where it's just all the same. Like if the point of comparison is like in relational reasoning, and then you're just like yes, 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 yes. I don't think that really tests anything. I would not like to see that one. But with respect to your question, wherever the point of comparison leads in your analysis, that's where we want to go. Is this clear to everybody? If doing 4 is the same as doing 2, understanding the differences and similarities between each one will help us identify a point of comparison from which, again, I will be very, 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 I will act in good faith. 2-word responses work if it's very clear what we're understanding, right? I don't want full sentences, right? Just clear, direct statements, yes.
We can do bullet points for like the questions. It doesn't have to be sentences. For like all the questions, not just the
If you get the point across, yeah. Yeah.
Is this online again?
It'll be online again. Cool. All right, if you have any questions, concerns, you can email me. We will also, just email me if you have any questions. If you have any questions about problems that you're thinking about, email me, and we should be good to go. See you all Thursday.